Hello, I'm just going to go over a quick introduction to Python 3. Um, it's going to assume you have Python 3 installed, and also it's going to assume you have this IDE called Pycharm installed, which is a nice way for beginners to start using it. If you need help setting up these things, there's I could create another video for that. So if you open up Pycharm and go to create new project, you can just call it learn Python, let's say, and make sure you have Python 3 here selected here. Here's my Python 3. So if you type which Python 3, I'm going to add a local interpreter. I'm not sure why mine's not there. User local bin. Python 3. Okay, I guess I did have it there. Yeah, so basically Python is a high-level programming language that lets you write scripts, but you can also construct software, some serious software applications using it. And it's often thought of as a very readable glue language, meaning you could sort of bridge the gap between different software systems, interface to many different systems online, just do one-off scripts. It's very flexible and is designed to be sort of general purpose. So this is the IDE. On the left you have this toolbar, on the right you have the content area where you can edit the files, and if you go new, right click and go to new Python file. You could create something called built-in types as your first file. As you can see, I named them all lowercase with underscores. It's sort of how Python conventions go for naming modules and variables. So this is the first program that we're going to write, and let me navigate to this. So it's going home to using cd tilde, and then Pycharm, my Pycharm folder. This is in Pycharm projects learn Python. And as you can see, my built-in types are here. So if I wanted to execute this, there's nothing in it right now. I type Python 3 built-in types. If you press tab, it'll just auto-complete it. And nothing happens because there's no code, but that's how you execute it in a one variant of how to execute it. Typically, if you want it to be executable through your shell, as in if you want to just execute it directly doing something like this, the first thing you have to do is give your file the execute permissions. And the second thing you'd have to do is most of the time you'll have to specify where the interpreter is, or the program that will actually launch the script, or else how would it know to run Python 3? And you could do this by prepending this to the top of the script. And the reason I know where that is, if you type which Python 3, it says, oh, okay, this is where your Python 3 is. So, oh, I must have mistyped it. Yep, that should do it. So that's great. There's one slight problem though. If you're running a different system, a different operating system, this is often not where Python is located. Like on my Ubuntu box, it's somewhere else completely. So One other way to do that is you can use this built-in program called env, which shows you all your environmental variables, and also is smart enough to use a path variable to know which Python 3 you're talking about. So the convention to make your code more portable is to use this to launch it. So if you copy this and paste it, so this will say, okay, launch this thing called Python 3 using env. So env is smart enough to know where it's located. And that will make it sort of more portable. So that works. You'll also notice that it says Python 3 specifically. So if you type which Python, you very likely already have Python installed if you're running a Unix-like system, like based off either Linux or BSD, like OS X. They usually have Python 2 already built in. That's default Python. So if you type Python, it'll just say 2.7.13. This is going to be a default for quite a while, since it's still the most popular and used Python version. So keep in mind that when you do this, it expects the Python 3 dependency interpreter to be installed, and it won't necessarily run off the bat on most systems. So we're definitely creating it for Python 3 exclusively by doing this. So that's just an example of a Hello World app, but we're going to explore built-in data types. So let me create a new tab here. So when you open the Python 3 shell and type help object, help is a built-in function which gives you a document explaining certain topics about objects that you put in the parentheses. It's just like calling a function. And there's this base object called object. It says help class object and module built-ins, and just says object is the most base type. So every single object in Python, which is sort of like the units in Python's memory in its runtime, is an object. Every single piece of data that has both data and behavior is an object. And there's different types of objects. And so objects have a type, and they have an ID. The type is, the base type is called type of object, and the ID is the memory address. And objects are full with other objects. So from the Python's perspective, everything's an object. It's kind of a interesting object model happening in the background. Takes a kind of a while to like wrap your head around, but it seems to be pretty consistent, and just something to keep in mind as you go over the types we'll be going over as it becomes more sort of as we explore better abstract data types. So sort of the second most important object and object type is the none type. If you type none, by the way, typing in just none like this, that's an expression or an expression statement. It won't do anything. So the type of none is none type, and there's a memory location for this object somewhere, and it only has one value. So besides expressions, you can create variables. So let's say I want to create a variable called a. Say a is a variable that is bound to the value of the object none. Its value is none. So since the none type only has one possible value, it is called a singleton. That's what it means to have a type that only could have one value. So unlike other languages, a points to this none object, and after setting b equal to a, b also points to that none object. So if you do id of a, id of b, it's the same object. Id of none, now they're all pointing to the same object. That is the most basic type. and it's usually used if you want to initialize a variable, but you don't really have a specific type you expect it to be. So going on to the next object, you could assign your variable a to a boolean afterwards. And booleans have two possible values that they could be. A could now points to the object true, which is a boolean. Type true is a boolean. Type false, boolean. So none starts with a capital letter, true starts with a capital letter, false starts with a capital letter. Those are the only reserved words in Python which start with a capital letter. And they're sort of related to the most simple types, simple built-in types. So the first thing we explored here is none object is equal to none. Not much you could do with this thing. Second thing is bool object true, bool object false. So these are really simple data types. As you can see, my naming convention here is just all lowercase underscore, similar to how I named the module. And by the way, this script name, this file name, from Python's perspective is a module. And like everything else, there's an object representing this module as well. So with Booleans, these are pretty useful for the language for doing a variety of things, especially control flow. So if you execute this piece of code, if I just did, still nothing happens, but what it does is it says, okay, I'm going to run this thing using Python 3. First, create a variable in the global scope. So in this module, there's a scope. There's already a scope in every module called the global scope, which is basically where all the variables go. It says none object. The variable none object is bound to none, the object none. So it runs through line 3, then it runs through line 5, then line 6, and it just exits. So it creates these variables and it binds them to these objects. If they're not in memory, it creates the objects. And then once it goes out of scope, once the execution finishes, the interpreter starts cleaning up and just gets rid of these variables. So those are two of the built-in types. And by control flow, what I mean is instead of going in order through the code, sometimes you might want to branch off. So one of the most basic things you could do is create an if statement. This is the most basic type of branch. A basic if branch statement. So this is what happens here is this built-in keyword if, it can't be you can't have a variable named if because it's built in. Same way you can't have a variable named none, true, or false. It will just not be able to, it's not valid syntax. Just the rules of the grammar of the language. And so it says if means I'm going to be expecting a Boolean expression after, and if it happens to be true, then I will execute this line of code. And as you can see, there's this colon here, and that says that's the end of this if statement. And there's 4 spaces here. So I pressed tab to get this to get it this far, but these are actually 4 spaces. And Pycharm knows, hey, I'm working with Python, and Python files work better when you use spaces instead of tabs. If you put a tab, it'd be considered a 1 character in some different editors, and that would cause compatibility issues with other scripts that people wrote. So in order to be more universal, the community decided 4 spaces is the right way to organize a block. But it's just handy to use tab, and it's good to use text editors that have that ability to handle that. This is a basic else branch. Basically, if you use something like Notepad++ or some other editor, or even Vim, you have to configure it to convert for Python scripts without py files to convert tabs to spaces, or else you're going to run into problems later. So this is pretty basic. If it's true, it'll execute. If not, if any other case, it'll just run this. So if we run this now, it hits this execution code, and that it executes that and stops running any more branching instructions related to this entire if else thing. So never hits line 11. And that's what booleans are used for. If I put false here, it hits the else branch. And there's also one more construct. This is a basic else if branch. So in this case, it's only going to hit one of these. So this time it's going to say if false, it's not going to execute. Else if true, it will execute this, and it won't even try the last one, because as it starts, once it executes one, that's it. And that's pretty much how if statements work. They work with Boolean values. So that's what Booleans are used for. But there's all sorts of cool operations you can do on Booleans. So one of them is you could do a basic not. So this is an example of an operator called not, which has an arity of 1. That means it takes 1 input and returns 1 output. Arity just means the input of an operator, how many items it could take. So what this does, it says, okay, I know I'm going to have a bool to the right of me, and I'm going to just invert it. And if you print bool not example, it'll be equal to false, because the not of true is false. So here's I'm going to comment this out. If you hold command and slash, I think it's some other shortcut in other versions in other operating systems, but it just comments it out. It has these little shebangs in front in order to make that code just like something you could read but doesn't get executed, so programmers use it to take notes. Or you could comment out code and comment it back in later. So this is an example of the first Boolean operator. Other Boolean operators are the AND operator. So the AND operator requires that both the left and right side are true if you want a result of true. And in other cases, it will give you a false. So it's like stating two facts that must be both true. If you say it's true that this and is true that that, they must both be true to be true. And in all other cases, it'll be false. So this AND operator has an arity of 2 because it takes 2 inputs. So the truth table for it is basically just to give an example, F stands for false. 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 Yeah. So if you have a Boolean which could have 2 values, and operator like and, which has an arity of 2. That's 2 to the power of 2 combinations you could have. So it could be false, 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 true, true, false, true, true. These are the results. So that's how the AND works. There's also a bool or example. So it's the only way to have a bool be false if both are false. So if you take this example, this is the only case where, there you go. Yeah, so the only way to get false is if you have 2 false inputs. It also has an arity of 2. And that's sort of like the most basic operations you do with bools. And that, I think that covers bools for the most part. One thing to note is that the next data type, the built-in data type we're going to cover is integers. So she did int 5 equals 5. These are bad variable names, by the way. You should not name your variables this. I'm just doing this for showing you. So an integer is a whole number that could be negative as well. So like essentially like negative 50 or 500 or 0. They are not decimals. And they could do basic operations on them. So you can use Python as like a calculator here. So if you did something like 5 plus 5, 5 times 5, or 5 divided by 5, it functions like a calculator. So one of the interesting things here is when you do 5 divided by 5, it doesn't give you an integer back. So if you do type of 5 divided by 5, it's class float. So decimals are sort of rational numbers that have a decimal value are called floating point because they have this dot that floats around.